Okay, in 2-4, we're going to look at finding trig functions for basically any angle, any general angle. Okay, so they tell us here that, or let theta be any angle in standard position and let A, B denote the coordinates of any point except the origin on the terminal side of theta. Okay, if r is equal to the square root of a squared plus b squared, which is just our Pythagorean theorem or a result of it, if that denotes the distance from the origin to the point AB, then the six trigonometric functions of theta are defined as the ratios. Well, I'm going to tell you, this is how we're going to do it. We're going to start here at the point, and I'm going to draw a perpendicular to my x-axis from the point. Okay, and I'm going to, even though this is theta, we're going to look at this point, and if we want to, we'll call it theta prime. It's not quite theta, but it's going to work for us. Okay, so for theta, still, this is my opposite, which would be a height of what? What is this height? If this point is AB? B. And this distance is A. Okay, so you can see that the way that we've defined the different trig functions is still consistent with opposite, adjacent, and hypotenuse. For sine, we would look at opposite over hypotenuse, which comes up to be b over r, right? For cosine, it's adjacent over hypotenuse, so it's a over r, okay? For tangent, it is opposite over adjacent, so b over a, okay? All right, and the same thing would be the case for cosecant. So to me, the a and b is really kind of arbitrary. We can always think in terms of opposite, adjacent, and hypotenuse. Okay, everybody sees how we did that? All right, let's look at it in an example, just to be sure. Okay, it says, gives us a few steps to help us do this. We have a point AB on the terminal side of an angle theta. We want to find the exact value of each of the six trig functions of theta. Okay, so this is good. So I get, first I'm going to draw my picture. Okay, minus 12, 5 is in quadrant what? 2. Okay, so we're going to draw a terminal side over here and label a point, minus 12, 5. If I drop my perpendicular, okay, to the x-axis, then I have this side is going to be what? Negative 12, and then this side is 5. Okay, we can use, in the next step, we're going to use the Pythagorean theorem to figure out the length of the hypotenuse. So we can say r equals the square root of 5 squared plus negative 12 squared. Okay, we get square root of 169 or 13. 5, 12, 13 is another Pythagorean triple. Okay, so that's one we might see from time to time, and you could remember. Okay, now that I have that, this is 13. Okay, then from here, we're going to look at our trig function values. Sine, and I'll write it here because I'm going to, but on the next page you have some space, I think. Sine of theta is going to be opposite over hypotenuse, so 5 over 13. Cosine theta is what? Adjacent over hypotenuse, so that's going to be negative 12 over 13. Okay, tangent of theta is, okay, so minus 5/12. Okay, questions about that? Um, Just when I did it on the calculator, it came out to square root 169. Square root of 169 is 13. Okay. All right. The reciprocal of sine is what? Cosecant. Very good. So cosecant theta is going to be 13 over 5. Then secant theta is negative 13 over 12. And then cotangent theta is negative 12 over 5. Okay. And so just given the point on the terminal side, we were able to find the values of all of our trig functions. Okay. Questions about that? Okay. All right, you ready to try that on your own? Okay, try it on your own for the point negative 2, negative 2. Okay, so which quadrant is this terminal side located in? Okay, 3. So we got negative 2, so we're down here. Okay, we got negative 2, negative 2. So we get r equals the square root of negative 2 squared plus negative 2 squared. So that's 4 and 4, 16. Does it come out to be 4? Is that right? No, that's 8. So it's 2 root 2, sorry. Okay, 2 root 2. Okay. All right, so now we have all of our sides. We're going to look at them from this angle, always from the terminal side back to the x-axis. And so when I do that, I get sine theta is opposite over hypotenuse, so negative 2 over 2 root 2. Okay, so looks like the 2's cancel, 1 over root 2 or negative root 2 over 2. Okay, cosine theta equals what? Adjacent over hypotenuse, so it's going to be the same thing. Negative root 2 over 2. Okay, tangent theta is opposite over adjacent, so negative 2 over negative 2 or 1. Okay, then we've got our reciprocals, so we've got cosecant theta is going to be just negative root 2. Secant theta is also going to be negative root 2. And then cotangent theta is going to be equal to 1. Okay, questions about that? Okay. If you had to guess the measure of this little angle, what would you think? What would you say it is? 45 degrees, right? This looks like the 45-degree triangle that we talked about last time. Okay. All right, and it's going to be important to recognize that. Okay, any questions about this? Okay, excellent. All right, what about our quadrantal angles? Okay, it says what we're going to look at, this is the way we're going to look at this. I need to change this in the notes. But for the quadrantal angles, and really anytime we're on a unit circle, okay, when we're on a unit circle, we're going to think of the coordinates as cosine theta, sine theta, okay? For a unit circle, okay, xy can be thought of as cosine theta and sine theta, okay? So what I'm going to do is draw my angle theta. Okay, here we're talking about 180 degrees. Okay, I'm going to put a point 1 unit from the origin, And then I'm going to think about what the coordinates of that point would be. Okay, what are the coordinates of this point if it's 1 unit from the origin? Or -1, 0, right? Since we came over to the left. Okay, those are our coordinates. So I can say from that sine theta, or sine of 180 degrees, since that's what we're talking about here, is going to be equal to 0. Cosine of 180 degrees is equal to -1. Okay. Tangent of 180 degrees is what? If we only know sine and cosine, how do we find tangent? Tangent is, well, we don't have opposite and adjacent, so sine over cosine, 0 over -1, or just 0. Okay. All right. Cosecant then of 180 degrees is going to be what? Not 0. What is it? Undefined. All right. 1 over 0 is undefined. Okay. Secant of 180 degrees is -1. And then cotangent of 180 degrees is going to be what? Undefined. If tangent came out to be 0, we flip that, it's undefined. We cannot divide by 0. Okay. Questions about that? It's a lot of information, so got to start pulling it together if we're going to take a test next week. All right. So that brings us to our quadrantal angle study handout. All right. So we need to know, we need to be able to fill out this table. Okay. And not just this table, but more importantly, as we go on through the course, when I say what is sine of 270 degrees, I need you to be able to tell me that information. So let's just kind of get it started here. For a radian measure, we're going to do 0 radians, 0 degrees. What are the other quadrantal angles? We know them in degrees, hopefully. 90 degrees, 180 degrees, 270 degrees, 360 degrees brings us back to 0, okay, where we started. Radian measure for 90 degrees is what? Pi over 2. Okay, 180 is just pi, and then 270 is 3 pi over 2. Okay, we're going to think of sine theta as y and cosine theta as x. Okay, and then the rest in terms of sine and cosine. Remember last time we said every function can be defined in terms of sine and or cosine. So you need to make sure you know those definitions. All right, I'm going to do one more. We just did 180, so you could fill that line out. Let's do 270. All right. the coordinates of this point, if it's 1 unit from the origin, would be what? 0, -1. Okay, that's right. So sine of 270 degrees is what? If I'm thinking of these coordinates as cosine theta, sine theta, okay, -1. Cosine of 270 is 0. Tangent is going to be tangent is what? Undefined is sine over cosine. If I have -1 over 0, that's going to be undefined. Okay, all right. Cosecant is going to be -1. Cosecant is the reciprocal of sine. And then secant is going to be undefined. And then cotangent will be 0. It's going to be 0. Okay, cotangent would be cosine over sine. 0 over -1 is 0. Okay, so remember 15 points on the test, and we need to figure out which day we're going to do this. So maybe Thursday of next week, when we come in, the first thing we'll do is I'll give you a chart that has similar lines across the top for sine, cosine, tangent, all the functions. You'll have 30 degrees, 60 degrees, 45 degrees. I'll give you one of these quadrantal angles. Okay, so which one, it'll be randomly chosen, but you need to be prepared to fill it out for one of the quadrantal angles and then one other angle that we've not talked about yet. Okay, so don't forget about that. All right, that's why I'm having you do all the table practice and stuff like that. Study that over the weekend and try to be familiar with all of that. Okay, so that should be due on Tuesday. Okay, we have no more time to waste. So Tuesday. Okay, coterminal angles. Okay, coterminal angles are not so bad, okay, because it doesn't really matter when we're evaluating a trig function. It doesn't matter how many times we've gone around. It only really matters where that terminal side is located. So we say two angles in standard position are coterminal if they have the same terminal side. Okay, yes. All right, they're coterminal if we have the same terminal side. All right, so in this case, -70 and 290 degrees are coterminal. -70 would be in which quadrant? 4. Okay, so I could say this is -70. But then I could also say that this is 290 degrees. Okay, it's a little bit past 270, 20 degrees past 270, same location, right? So we said they're coterminal, all right? 20 degrees and 380 degrees, okay? We're in quadrant 1. 20 degrees might be about here. And then 380 degrees is going to go around one full time and then 20 more degrees. So it would be here as well. Okay, 380 degrees. They are coterminal. All right, coterminal angles differ by 360 degrees or 2 pi. Okay, and most importantly, since coterminal angles have the same terminal side, the value of the trigonometric functions of coterminal angles are equal. I know that sine of -70 degrees is equal to sine of 290 degrees because they are coterminal. Okay, that's just an example. Okay. So usually we try to think in terms of angle measures between 0 and 360 because everything has to be coterminal to something in that range. Okay. So for instance, if I want to, not that one either, too much stuff. If I want to evaluate sine of 405 degrees, well, I'm going to try to get 405 or find an angle that's coterminal to 405 degrees between 0 and 360. And really, the only thing I need to do is just subtract 360 degrees. We get what? 45 degrees. And we should know everything that there is to know about a 45-degree angle. So sine of 405 degrees is equal to sine of 45 degrees is equal to what? Now, what's sine of 45 degrees? Root 2 over 2. Root 2 over 2. Sine of 45 degrees is root 2 over 2. We got to know that. Okay. Cosine of 480 degrees, well, if I subtract 360 from 480 degrees, okay, then I can say cosine of 480 degrees is equal to cosine of 120 degrees, okay? And I'll just put dot, dot, dot for now because we don't know how to evaluate that yet, but we will in the next day or so. Okay, so just make sure I come back to that one. Okay, this one is really not a good one. Let's do something else. Let's do, let's say 9. Let's do 8 pi over 3. That's better. Okay, let's say tangent of 8 pi over 3 over 3. Okay, then I want to subtract off 2 pi, or in thirds, 2 pi is how much? How much? 6 pi over 3, right? Okay, if I subtract off 2 pi, that's 6 pi over 3, we get 2 pi over 3. So tangent of 8 pi over 3 is equal to tangent of 2 pi over 3. Okay, so if I know which 2 pi over 3 is what? 120. Very good. All right. I won't write that down. We need to think that mentally. But so again, 120 we don't know how to evaluate yet, but we will come back to that.
Wouldn't C be a radian?
Say that again.
Wouldn't C be a radian since B was
It is, and that's why I didn't subtract 360. I subtracted 2 pi. Yeah, 6 pi over 3 is 2 pi. So if we're in radian measure, we would have to subtract 2 pi.
okay.
Okay.
Well, you didn't really subtract 2 pi, you subtract out 6 pi.
But 6 pi over 3 is equivalent to
Okay.
2 pi. Okay. All right, other questions? All right. All right, I'm gonna, so much to talk about. Okay, we'll come back to these things if we need to next week. Yes. Okay. All right, signs of trigonometric functions, which is a third worksheet. I think there's one called signs of functions or something like that. SIGNS functions. But we know the sign of a trigonometric function based on the quadrant that it's in. Okay, so over in the first quadrant, if we're looking at the coordinates, we have positive x, positive y, right? Is that right? Okay, and we just said that sine is going to be the second value. So in the first quadrant, sine is going to be positive. In the second quadrant, cosine is positive. Positive over positive gives us positive. Okay, so in the first quadrant, all of the function values are positive. Okay, in quadrant 2, what do we have? X values are negative, y values still positive. And remember, we're thinking of this in terms of cosine theta, sine theta. So in quadrant 2, who's positive? Nope. Sine is positive, right? In quadrant 2, we've got a negative and then a positive. Yes? Okay. If you're over here in this quadrant, we had to give you a negative x value and then a positive y value. Okay. If we think of this as cosine and then sine, sine is positive, cosine is what? Negative, and tangent is going to be what? Negative. Okay. In quadrant 3, we have negative, negative. And so sine is going to be negative, cosine is going to be, tangent's going to be positive. Very good. Okay, we're getting it now. And then in the fourth quadrant, we have positive, negative. So sine is going to be what? Negative. Cosine, positive, tangent, negative. Okay? So we have to have a way of memorizing this information. Which functions are positive or negative in which quadrant? And so in the first quadrant, it's all of them, right? In the second, it's what? Sine and its reciprocal, which is cosecant. Okay? In the third quadrant, it's what? Who's positive? Tangent. Okay, and its reciprocal cotangent. And in the fourth quadrant, cosine. Okay? So we got to remember ASTC. All students take calculus, Appalachian State Teachers College, whatever. Okay? But in the first quadrant, they are all positive. Okay? In the second, sine was positive, sorry. In the third, tangent and its reciprocal are positive, and cosine and its reciprocal are positive in the fourth quadrant. Okay?